And then we have this one on the same graph, on the same diagram. Sketch the graph of y is equal to the modulus of 4 cos x and y is equal to 2.5 for the domain 0 to 2 pi. Hence, state the number of solutions of the equation 14 cos, the modulus of 4 cos x is equal to the square root of, is equal to 2.5. So to solve this, I've decided to draw this in advance, but I've skipped the x-axis so that I can show you how to pick the numbers. So for the y-axis, you have not been given the range, but you know that when you have something like this, the maximum you can go is 4. This one here is telling you the amplitude of this wave. And then you also know that this thing, because of the modulus, you don't expect any negative numbers, but I've decided to include them just to show you how to get this from this. So I'll put the domain. So our domain here will be, the maximum you can go here is this one. So when you've been given radians, stick to radians. There is no need to use degrees. So halfway between 0 and 2 pi, you have a pi. If you want, you can find the average between these two by adding 0 to this and dividing by 2. And then halfway between 0 and pi, you have half pi. To find this, you can find the average of these two. The same applies to this. Halfway between pi and 2 pi, you have 3 pi over 2. So to find this, you can as well just find the average of these two. So, or the midpoint, whatever you want to call it, you have this. And then to sketch this, you know that the cosine graph, a normal one, will start from here. If you had something like y is equal to cos x, because cos 0 is 1. So yeah, and then from here we can see that we have a 4 there. So this 4 is the amplitude, the distance from the center to the highest point. That's what this 4 is about. So instead of starting from here, in case you are not very sure where to start from, you can as well just say y is equal to 4 cos. At this point, x is 0. So this will tell you the starting point. Cos 0 is 1. So you are starting from here. And then remember that the cosine wave will look something like this. It will be something like this. So in a case where the amplitude is 4, you start from here, and then you still have to pass through this point, but I'm not going to draw whatever is down there. I'll make a broken line instead. And then remember that the amplitude should be 4, like this. So you have something like this. Actually, this one will be solid. So I've decided to make this one broken because I don't need it. Make sure you are using a pencil. I used a pencil when I was trying it out, but it was not very clear, so I decided to use my special pen. Yeah, so when you look at this, y cannot be negative. So everything that is negative cannot appear on your drawing. So we have some negative part here, which explains why I decided to draw a broken line. So when you have some negative part, make sure that you reflect it upwards. So you can just assume you have a mirror here, and then you are looking at it. You are looking at this line through that mirror. So what you'll see on that mirror will be something like this. Yes. So this is the graph of y is equal to the modulus of 4 cos x. Like this. It's this easy. Just remember to reflect anything that is negative up. Because you don't expect any negative y values from here. And then the other part is saying this one here. So you're not just sketching the graph of this. Make sure you sketch the graph of this one too. So the graph of 2.5. I left my graph papers somewhere, but the 2.5 is supposed to be somewhere here. I don't need to extend it this side because the domain is saying from 0 to 2 pi. So you don't need anything that is outside the domain, and you don't need anything that is beyond this point here, the maximum. The maximum value of x in the domain. So now the second part is saying hence states. We have this nice word here. So when you have this word here, states the number of solutions of the equation this. You don't have to solve for x here. You just have to state using the information you have so far. So remember that when you are solving two equations simultaneously, as you can see, this is like the equation of this and the equation of this being solved simultaneously. After you substitute this thing in there, you get this. So the number of solutions from here will be the number of times the straight line y is equal to 2.5 meets the wave y is equal to the square root of, the modulus of 4 cos x. So in this case, the number of solutions will be 1, 2, 3, 4. So you expect 4 solutions from here. You really don't have to solve for x. So you are done the moment you just write this.